right, guys, so I'm going to go through the mini quiz for April 1st. No, I'm not kidding. So it was, a train's velocity on a railroad track measured in meters per minute is given by a differentiable function v of t, where t is measured in minutes. Selected values for v of t are given in the table above. All right, so if we are going to approximate the acceleration at t equals 10, so we are going to do, acceleration is the derivative of the velocity. We don't have the equation for the velocity, so therefore when we think derivative, we think slope. All right, so louder for the people in the back. So if we are trying to find the acceleration at t equals 10, we're going to use the slope at the two closest points, which are going to be 8 and 12. So we do y2 minus y1 over x2 minus x1. So we get 60 over 4. All right, so we get a of 10 equals 15. And then we want the units, so meters per minute divided by minutes is meters per minute squared. All right, so does the data in the table support the conclusion that the train's velocity is 20 meters per minute at some time within the interval from 0 to 12? Give a reason for your answer. All right, so from 0 to 12, is there somewhere where if this is a differentiable function, my velocity is going to be 20 meters per minute? So it goes from 0 to 100. Would it pass through 20 there? Yes, it would. It would pass through 20. So some point between 0 and 2, my velocity is going to equal 20 because v of 0 is equal to 0 and v of 2 is equal to 100. So therefore, 20 is between 0 and 100. So then we go from 100 to 40, then from 40 to 0, that's another place from 40 to 0 is where it's going to hit 20 once more. So between 5 and 8, v of t is going to equal 20. So because v of 5 is equal to 40 and v of 8 is equal to 0, therefore v of t is equal to 20 is in between 40 and 0. So that's another point. So we have one time between 0 and 2, another time between 5 and 8, and then one more time it goes from 0 to 60. So 20 is going to be somewhere between 0 and 60. So at one more point in time between 8 and 12, v of t is going to equal 20 because v of 8 is 0 and v of 12 is 60. All right, aka all this is the IVT, the intermediate value theorem. So it does equal 20, a velocity of 20 at actually 3 locations because of the IVT, and we just showed what the values are that bookend those points where 20 would fall in between them. Okay? So the next one, does the data support that the train's acceleration, that the conclusion that the train's acceleration will equal negative 20 meters per minute squared at some point in time between t equals 2 and t equals 5? So the first thing, acceleration is the derivative. And this kind of is leading me to be like, hey, it's probably a theorem. So the theorem of the derivative one is the mean value theorem. It says the derivative, which in this case, the derivative of velocity is acceleration, right, because that's v of prime of t, is going to equal the slope connecting those two endpoints. Well, let's find out what that slope is connecting those two endpoints. 5 minus 2. So 40 minus 100 is negative 60 over 3, which is negative 20. So because of the mean value theorem and the slope connecting those 2 points of 2 and 5 is equal to negative 20, we know that the train's acceleration will equal negative 20 meters per minute sometime between 2 and 5. All right, last one, the trapezoidal sum. Use that to approximate the integral from 0 to 12 of v of t dt with 4 subintervals. So trapezoidal sum is 1/2. Now we're going to do the distance between 0 and 2 is 2 times, now when we do left Riemann, we would pick 0. If we do right Riemann, we would pick 100. But because this is trapezoidal, we're going to do 0 plus 100 because we're doing the 1/2 base 1 plus base 2. All right, plus. Now the distance between 2 and 5 is 3, so we're going to do 1/2 3 times. Now left we would pick 100, right we would pick 40, but with trapezoid we do 100 plus 40. Plus 1/2, the next one is between 5 and 8 is a distance of 3 times, and then we take those two, 40 plus 0, plus, and then there's one more that we're going to add to that. I just kind of am running out of room, so let's see if I can squeeze it in. 1/2, the distance between 8 and 12 is 4 times 0 plus 60. Yep, squeeze that right in there. That's 0 plus 60. All right, so now because of that, we can box that in as our answer for the AP Calculus exam. We do not need to calculate that out. Now we're doing base times height with all these, so meters per minute times minute, that's the total distance traveled by the train in meters from 0 to 12 minutes. Make sure you put the 0 to 12 because that accounts for the bounds. All right, that's it.